the sun shuts off, and civilization realizes it never understood what it was standing on. Imagine that tomorrow, exactly at noon, the sun simply turns off. No explosion, no warning, no cinematic apocalypse, just darkness for 24 hours. What fails first? The cold? Food? The internet? Or something far more fragile? Humanity's illusion of control. Today, you're going to walk through one of the most disturbing thought experiments in modern planetary physics. And by the end, you'll understand why the sun was never just a star. Before we continue, a quick request. If this kind of content expands how you think, subscribe to Flux Intellectus, like the video, leave a comment, and share it. This isn't just about growing a channel. It's about keeping alive a space where science, energy, and consciousness are treated with real depth. Now, let's continue. The sun is not just a bright object in the sky. It formed about 4.6 billion years ago when a massive cloud of gas and dust, rich in hydrogen, collapsed under gravity. As that collapse intensified, the core became dense and hot enough to ignite nuclear fusion. At the sun's center, hydrogen atoms fuse into helium. A tiny fraction of mass is converted directly into energy, described by E equals mc squared. That energy takes hundreds of thousands of years to travel from the core to the surface before escaping as light and heat. The sun remains stable because two forces are perfectly balanced: gravity pulling inward and fusion-driven energy pushing outward. It contains over 99.8% of the mass of the entire solar system. Its gravity keeps planets in orbit. Its radiation defines days, seasons, and climate. Its energy powers photosynthesis, the foundation of nearly all complex life on Earth. Every piece of food, every forest, every fossil fuel, and a large portion of the electricity we use today is, ultimately, transformed solar energy. So when we talk about the sun going dark, we're not talking about losing light. We're talking about interrupting the fundamental physical engine of civilization. In the next minutes, we'll conduct a rigorous thought experiment, anchored in known physical laws, real observations of Earth's climate system, and behaviors already measured in climate models, eclipses, and energy networks. Step by step, we'll answer one extreme question. What would actually happen if the sun stopped emitting energy for 24 hours? You'll understand the first 8 minutes, the first hours, what happens after 12 hours, and what emerges at the 24-hour limit. And more importantly, what this scenario reveals about our energy dependence, our systemic fragility, and the kind of civilization we've built on invisible assumptions. Let's dismantle a common myth. If the sun shut off, Earth would not freeze instantly. Thermal models show that oceans, soils, and the atmosphere have enormous thermal inertia. Stored energy doesn't vanish in hours. There would be no global freeze, no immediate extinction. The real problem is not physical at first, it's systemic. At the exact moment the sun stopped emitting energy, nothing would immediately change on Earth. Sunlight takes 8 minutes and 20 seconds to reach us. During that time, airplanes keep flying, hospitals keep operating, markets stay open, people follow their routines. Physically, Earth is still living in the past. Civilization continues, unaware that its primary energy anchor has already disappeared. When the final photons arrive, external energy input drops to zero. The sky goes dark, not like a normal night. No twilight, no scattered sunlight. The moon reflects nothing. For the first time in modern history, humanity observes Earth with no incoming external energy. But darkness isn't the main issue. The real impact begins in the planet's energy balance. Without solar input, Earth immediately begins losing heat to space. Not uniformly. Climate models show continents cool faster than oceans. Dry regions cool faster than humid ones. Atmospheric pressure gradients reorganize. This isn't sudden freezing, it's continuous thermal drift. The planet enters a dissipative regime without replenishment. Photosynthesis stops instantly. Plants don't die within 24 hours. That's well established biologically. But the primary energy flow of the biosphere is interrupted. Life continues by consuming stored energy. Now we enter the human domain. Without the sun, solar generation drops to zero. Weather forecasting loses key inputs. Electricity demand spikes for lighting and heating. Power grids are designed for predictable variation, not the total loss of the diurnal cycle. The result isn't a simple blackout, it's cascading instability. Imagine a major city, hospitals, data centers, water pumps, no solar input, simultaneous demand peaks. The grid doesn't fail from lack of technology, but from excessive coupling. Satellites depend directly on the sun. Without radiation, solar panels don't recharge, thermal systems enter survival mode, instruments shut down, GPS accuracy degrades, communications become intermittent, not because of malfunction, but because of basic energy limits. After about 12 hours, temperature drops become measurable. Biological cycles desynchronize. Abnormal animal behavior appears, similar to what's observed during prolonged eclipses. Insects reduce activity, birds go silent. The planet doesn't collapse, it falls out of alignment. Agriculture doesn't collapse in 24 hours, but modern logistics operate on just-in-time systems. Refrigeration, transport, and distribution depend on continuous energy. There's no immediate famine. There is exposed risk. After 24 hours, regional cooling, localized crop damage, partial energy failures, degradation of critical services. Nothing is destroyed, but everything is revealed. The sun comes back. Physics stabilizes quickly. The Earth system is resilient. Human civilization, less so. This experiment was never about the sun. It was about extreme centralization, lack of redundancy, invisible dependencies, confusing stability with control. The sun never promised permanence. We simply assumed it. In episode 1, we saw Earth accelerate. Today, we saw the opposite. What happens when flow stops? The message is the same. Complex systems demand resilience. 3 lessons emerge with brutal clarity. 1. Energy is infrastructure, not a service. 2. Redundancy equals survival. 3. Resilience is applied intelligence. Microgrids, distributed storage, local production, decoupled networks. This isn't futurism, it's defensive engineering. You don't control the sun, but you control your preparation. Knowledge, consumption, community. Civilizations don't collapse from lack of resources, they collapse from excess dependence. The sun has always been there, silent, constant, indifferent. Maybe the problem was never the sun. Maybe we mistook stability for entitlement. If this episode expanded your perception, subscribe to Flux Intellectus. Here, we don't react to collapse. We understand it first. Comment below which dependency disturbed you the most. Your answer helps map collective awareness. In the next episode, we flip the equation. What if energy became too abundant? Who would control power? And who would lose control? The sun owes us nothing. It never promised stability. Perhaps true intelligence is learning to live without absolute guarantees. Flux Intellectus, science, energy, and consciousness for a planetary future.